This is a trick shot performed by Brody Smith. The frisbee can be represented by the projectile motion diagram here. Segment 1, when the frisbee is released from Brody's hand. Using the known values, the velocity that the frisbee is released at was determined using one of the Big Five kinematic equations. Following the final velocity, the acceleration is calculated as well. Once the acceleration was discovered to be 1.46 meters per second squared, it was used in definite equation to solve for the applied force on the frisbee. But first, I drew a free body diagram of this motion. Segment 2, when the frisbee is in the air. To determine the initial velocity of the frisbee, I first calculated the x component of the velocity, then the y component of the velocity using the known values. Here I'm solving the y component of the velocity. Once I calculated the velocity components, I was able to calculate the initial velocity using Pythagorean's theorem. To continue, I used tan theta to solve for the angle that the frisbee was released at by using the v initial y and the v initial x. Next, the acceleration of the frisbee was calculated. Assuming that the frisbee will slow down and eventually come to a stop at the net, the VF was assumed to be 0 meters per second. Once the required acceleration was found to be negative 6.19 meters per second squared, a free body diagram of the frisbee was drawn. Then, first I solved the forces in the y direction, and it was calculated using the mass of the frisbee, the acceleration, and the force due to gravity. The force being solved in this equation was the lift force. Finally, the force of air resistance was calculated using the drag equation. The known values are the fluid density of the air, the velocity of the frisbee, the frontal area of the frisbee that's horizontal, and the coefficient of drag of a disc. conclusion, the most feasible explanation for Brodie Smith's trick shot is that in the first segment of the trick shot, he would have to deliver the frisbee so that when it leaves his hand, it should have a final velocity of 4 meters per second and an acceleration of 1.5 meters per second squared. Therefore, Smith would have to apply a force of 0.26 newtons to the frisbee when delivering it. During the second segment of the shot, the frisbee would have a velocity of 16.9 meters per second and at an angle of 54.6 degrees above the horizontal. So while the frisbee is in the air, there would be an air resistance of 3.4 newtons against the frisbee, and since the acceleration is negative, the applied force, it is normal for it to be less than the drag force, as well as the frisbee would be slowing down as it enters the basketball net, so the drag force would be greater than the applied force. And with this proof, the video of the trick shot is plausible. All I do is win.